Hey, IEP Bio, I wanted to make sure that you had a good view of how you actually work the old rubber band and thumb model of muscle contraction. So once again, a reminder, you should watch this video. I'll put the links on the website so that you understand what's going on within the model, and then you can model it on your own without the video playing and show yourself that you actually understand it. So this is what I came up with when I took the AP Bio exam back in the days of yore, the Middle Ages, and I still remember it, so it works pretty good. What you're going to need is get yourself a nice rubber band or one of those handy little Armstrong bands, even though he's not cool anymore. And you can put that on your wrist, or any old rubber band will do. Included with that, as I back up a little bit further, we can see that I've got this thing called my arm. This is actin. Actin is acted upon. If I look at that sitting on top of it, we can see that it has this rubber band, which represents tropomyosin. It is blocking the myosin binding sites at my wrist. And the other thing that I can see is this would have troponin on it, which is its control switch. Troponin turns it on or off. And I've got my other hand. My other hand represents, of course, a couple of things. One, it could be calcium ions, which would pump in from the sarcoplasmic reticulum. And then it's got this handy thumb. That is the myosin motor protein head, those creepy clown feet. And that can be activated by things like ATP, etc. So first thing that's going to happen, you're going to have a nerve fire. That nerve sends a message to the muscle that then allows it to release calcium ions from the sarcoplasmic reticulum to get down where the fibers are. That calcium ion can come down, and because of its charge and shape, it binds to troponin and turns it onin. That slides, changes the shape of tropomyosin to slide out of the way, exposing the wrist where I find my myosin binding sites. So this is actin. It's about to be acted upon by this thing called myosin. There's my mover head. Now, key thing, nothing's going to happen unless I have ATP. ATP comes down and binds to my thumb, the motor head, and causes it to go into its power stroke. It's cocking it back and loading it with potential energy. That converts ATP into ADP and PI. They are now, of course, stuck to that thing. As it pulls back, that changes its shape and conformation so that it is attracted over to the myosin binding site. As it attracts to that and fits into that groove, that's another charge and shape change. That kicks out the PI. Now just ADP is stuck onto my myosin head. When that change happens and that bond is broken, it goes through its power stroke. In the power stroke, that causes it to slide forward. That new change in shape causes it to change its function. That kicks out the ADP, releasing the shape and charge so that now it's open again and the parking spot is open. That would, if you have more ATP from your mommy bringing orange slices to the soccer game, allow ATP to bind again, convert into ADP and P, and pull back and load the myosin mover head, which puts in the right conformation to attract again. And it would continue to do that, binding, converting into the power stroke, sliding, until, of course, you slid the filaments by each other, making the muscle contract. So do not forget the parts. You got your actin that's acted upon. You got your tropomyosin that is blocking. It's controlled by troponin. It's turned on by calcium ions. ATP allows you to cock back the motor protein head and the myosin. Now that it's exposed, it can attract, kick off P, bend forward and power stroke. ADP pops up, it disconnects, and boom, you got some ATP coming in, and you can keep on doing it. If, of course, you were really, really, tired and you didn't have enough orange slices, now there's no more ATP to cause it to actually release, so it's just stuck, and you start to cramp up. Or let's say that you don't have enough electrolytes in your system because you didn't buy a Gatorade or you don't like drinking salt water, and you found out that now a flood of ions is preventing the calcium from binding to this, and now you can't actually get them to move. Hey, you're cramped up in a different way. All right, hope that was helpful. Try it a couple times. Not great in the video thing, but hey, it's better than not seeing it. Cool. This, of course, is the fancy version of it. Now you should be able to explain it with your arm model that you can take anywhere with you for the rest of your life as long as you have your arms. Yes.